Hi, my name is Jessica Prieto, and I am doing the concept of inertia. Inertia is normally known as just a mere concept, but when put in practice, we learn more about inertia. The most common known substance of inertia is the main definition, which is inertia mass is the resistance of an object. This meaning that when inertia is resisting, it's the weight of it. Inertia and mass are not the same thing, while many believe it is. For inertia is always classified as the resistance. So an example of it would be of an accelerometer on a table. When you put the accelerometer around a wheel and you spin it around, you notice that will the cork inside of it will stay pointing outside. This is of the mass of the cork is less than it is of the water, meaning that the cork is that the cork does not have the resistance any longer, and it is moving as the water. And this is just a concept. We always think of inertia as just, well, it's just energy. It doesn't do much. It's just kind of there. But actually, inertia is one of the most important concepts of all, because when you're thinking about mass or anything really, you think about what is moving and why it is moving. This brings us to the next point of what is gravitational, active gravitational, and passive gravitational. And active gravitational is when the strength of the gravitational force is the active gravitational mass is a measure that measures the strength of the gravitational field due to the particular object. This means that the active gravitational force is actually pulling the object more than the object is pulling the strength in. Then there is passive gravitational mass. The passive gravitational mass is the strength of an object interacting with the gravitational field. This is described in the accelerometer, and even though we can say that active gravitational is what is really contributing to it, it is actually passive gravitational mass. And there are many differences between them, but most of the time we just think that an object in a gravitational force stays the same. And this brings us to what is the difference between between the gravitational forces. And this would be that there's a lot of study that inertial mass equals as passive gravitational. The theory is that passive gravitational is the weak equivalence principle. This meaning that it has a weak force, but it is still a force. It's still a force that is passing from the object to where it is located. And for active gravitational is known as the strong equilibrium balance, and it is the one that is actually pulling the object down. So most of the time when a person is on Earth, we're actually having passive gravitational mass because the force is there and it is pushing us down, but we don't notice it. Now, if it were like a car falling on top of a car, a rock falling on top, we would think that this is actually active gravitational because due to the gravity, it actually stays. Between gravitational mass and inertial mass, there is really no difference other than the methods used to use it, which are either done on paper or on computer for either one of these. Now, one of the examples that we have for inertia is how we actually calculate inertia. The first example I'm going to show is looking for the unknown. The equation that we use for inertia is V final is equivalent to V initial plus acceleration plus time. And for this example, we are going to use the V final is going to be equivalent to 5 meters per second. The V initial will be equivalent to 2 meters per second. and the acceleration will be equivalent to 0.5 meters per second. And the time, now we'll just have to calculate for the time. So we put all of these together, and we find out that 5 is equivalent to 2 plus 0.5 t. Now we merely do a little math, subtract, where 3 is equal to 5t, and we find out that t is equivalent to 6. That is one of the easy examples that we have looking for that. Now, this example is one of the easy ones. But what about if the v initial is 0, like in many problems? Then we would come to, I'm going to move this more to the top. And now is equal to v initial plus 18. Then we bring to, let's say the v final is equivalent to 15 meters per second. V initial is equivalent to 0 meters per second. And let's say the acceleration is equivalent to 0.5 meters per second So what do we do now? We don't have a v initial. We still can put it into the equation as I'm doing right now, and we notice that it just kind of cancels itself out. So we're left with cancel itself out. We're left with 15 is equivalent to 0.5 t, and this merely shows that time is equivalent to 30 seconds. 30. And this is another one of the examples. Now, when we're looking at inertia, we also must look at what the direction it's going or how fast it's going. For example, for a car starting from rest and traveling for 10 meters per second with a constant acceleration of 3 meters per second, the driver then applies the brakes, causing a constant negative acceleration of negative 4 meters per second, assuming the brakes are applied for 2.0 seconds. So in this equation, what would we do? Well, as we know, the traveler is going from rest to 10 seconds at a constant speed of 3 meters per second. So we merely do a little math, which is 3 multiplied by the 10 seconds, and we get he is going at an acceleration of 30 meters. Now we're trying to find out how fast in the end he ended up going, and then we also see that the acceleration he accelerates has a negative acceleration of negative 4 meters per second, and he applies the brake for 2. So again, we do a little bit of math, and we get that he is a negative acceleration of negative 8. Now we merely put these all together, and because we already did the acceleration and the time right here, we already did it right here, we don't have to do it again. So we're calculating just for the v final, and we have 30 minus 8, which is equivalent to 22 meters per second, which is his final. Now, for this, we're assuming that he's going to. Now, for this equation, even though it's a word problem, sometimes they can trick you, but don't worry. Most of the time, if they're trying to trick you, they'll trick you in a way that is just merely tricks. Well, this is the end for my presentation. Thanks.